Ooh, I almost forgot to turn on the recording. That would not be good. Okay, so I have a couple problems from just like a review from last week. Last week we talked about the power rule. The power rule says if you have something like, oops, I better turn the marker on. It works a little bit better that way. If you have, let's say x, let's go 2x to the third power. The power rule says you bring the power down, so you just multiply that. So 3 times 2 is 6, and then you just subtract 1 from the exponent. So the derivative of 2x to the third is just 6x squared. And what does the derivative give us? It gives us a function that will give us the slope at any given point. So if I'm doing this problem, the first thing I always do is I always try to get everything out of the denominator, because you can't take a derivative. You can't bring the 6 down, and some kids try to do that. You can't do that. So I would rewrite this problem as 5x to the third plus x to the negative 6. Then I would just use my power rule. So this would give me 15x squared plus negative 6 x to the negative 7th power. That is my derivative for this function. So I would just rewrite it as y prime is equal to that. So if I wanted to know the slope of a tangent line to this graph, I would use this equation to find it. If we had something like this, I would rewrite this as 4. Oops, again, I need to turn my marker on. 4x to the negative 1 plus 4x to the negative second. So the first thing I do is I always rewrite the problem. And then after I rewrite it, then I take the derivative. So I use the power rule. So that gives me negative 4 x to the negative second plus negative 8 x to the negative third. So that was basically a real quick review of last week's material. All right. Then it says, write an equation of a tangent line. Okay. And you're going to be doing this all year long. Being able to write equations of tangent lines. So whenever you're asked to write an equation of a tangent line, the first thing you should do is you should always write down what piece of information you need. And the only two pieces of information you need is point and slope. Yep, exactly. So my point, well, they gave me my x value. It's already negative 2, so I know what that is. So I need to find a y value, which is really pretty easy. I just plug that in here. So I've got 3 times negative 2 squared plus 4 times negative 2 minus 10. Well, negative 2 squared is positive 4, so this becomes 3 times 4. So that's 12 plus negative 8 plus negative 10. So that's going to be negative 6 for my point. So now I have a point. Awesome. To get the slope, I need to find the derivative. Well, the derivative is the easy part. So that's going to be what? 6x plus 4. And then I put my x value back in there because I want to know what the tangent line is, x equals negative 2. So that's going to give me 12 plus 4, which is 16. So now I have a point and I have slope. Do not, and this is, some kids have been writing this in slope-intercept form, and it's like, man, they're doing a whole lot more work than you have to. Point-slope form is the easiest form here. So I'm just going to rewrite this as y plus 6 is equal to 16 x plus 2. Done. That's it. I don't have to go any farther. I do not have to write it in slope-intercept form. You can leave all of your answers in point-slope form. So just leave it just like that, and you are done with that problem. All right. Any questions with that? All right. So this week, we are dealing with trigonometric functions, the derivative of the trig functions. So we have to find the derivative of sine, cosine, tangent, cotangent, secant, cosecant. Oops, cosecant is this way. So those are all that we need to find. And we also have to find natural log and e to the x. So there's 8 derivatives. Now, when I first started learning calc, I would put them on 3x5 cards. And then, when I'm doing my homework, I'm just looking at these 3x5 cards. It's like, oh, and then after a while, they just become natural. I mean, it's like, okay. Now, I will tell you that these four, I don't memorize these four. Rarely do you ever have to use these in an AP test. These two, all the time. These two, all the time. So those two you'll get real used to using and finding the derivatives really easily. Okay. Now, the first thing I want to know before I get to there is how do you find the values of trig functions? Okay. So I'm going to ask you some pretty tough questions, and I want to see if you can answer them. What is the sine of pi? What is the sine of pi over 2? What is the cosine of pi? What is the cosine of 3 pi over 2? Do you know how to figure those out without a calculator? These aren't trig identities. These are just values. For example, another way of writing this would be, yes, the unit circle. Okay, do you have the unit circle memorized? Nah, neither do I. However, if you can memorize a few things, you'll be okay. And those things, and I'm going to give them to you today, and this will help you immensely when you're doing all these problems, because everything that we do today, I'll tell you that it will be, if you can, and you can, when you're taking the AP test, you can write anything down that you want. So the first thing I always told my kids when I used to teach face-to-face is I said, hey, draw out the sine function. Okay, so this would be pi over 2, pi, 3 pi over 2, and 2 pi. And the trig function, the sine function, always starts at 0, goes up to, and this is 1 here, goes up to 1, goes down, oops, and then it comes back up here. And this is -1 here. So if you knew what this graph was, and this is 90 degrees, sometimes they give it to you in degrees, sometimes they give it to you in radian measure. This is 180 degrees, this is 270 degrees, this is 360 degrees. Okay, so if you just knew what that graph looked like, okay, tell me what the sine of pi is equal to. So if you take a look here, sine of pi is 1. I disagree with that. Sine of pi is 0 because it crosses right here at 0. The sine of pi over 2, the sine of pi over 2, here's pi over 2 here, that is 1. The sine of 3 pi over 2 is right here, it is -1. The sine of 2 pi, 0. The sine of 0, 0. So this graph gives you the sine of 0, 90, 180, 270, and 360. Okay. Now we're going to do cosine. Cosine is exactly the same thing, except cosine, so this is pi over 2, pi, 3 pi over 2, and 2 pi. The only difference is cosine starts here, then it goes down, comes back up, goes here. Okay, so if I asked you what is the cosine of pi, what would you say? And I could write this down. This is pi over 2 here. This is pi, 3 pi over 2. Yep, -1 is exactly right. What is the cosine of 2 pi? Correct. So those two graphs will help you with 90% of all of the questions they'll ask you. Now the other ones are this. If you remember a 45-45 degree triangle, a 45-45 degree triangle is just half of a square, isn't it? So if you had a square and you just cut it in half, you get 45-45 degree triangle. Okay. So if this is the square root of 2, this would be 1 and 1, wouldn't it? So now, what if I asked you for the cosine of 45 degrees. What would you say? Well, cosine is adjacent over hypotenuse, isn't it? And sine is opposite over hypotenuse. Remember those trig things? So if I took a look at 45-degree triangle, this is the adjacent side, this is the hypotenuse. Cosine of 45 degrees would be 1 over square root of 2. Now, usually we don't leave a square root in the bottom, so most people would just say that's square root of 2 over 2. Okay, because I just multiplied top and bottom by square root of 2 to get rid of that. Now, you can check it on your calculator. Usually your calculator gives you a decimal. So that's one trig, that's one. And then if you remember, so if you remember this one and this one, this is a special triangle also. 30, 60, 90. If this is 2, this is 1, this is the square root of, is that the square root of 3 over 2? I always forget this one. I think it's square root of 3 over 2. A squared plus b squared equals c squared. So 3 plus, no, that's just square root of 3. Okay? As if you square a squared plus b squared equals c squared, right? So square root of 3 squared plus 1 squared is equal to 2 squared. That's 3 plus 1 equals 4. Yeah, that is correct. Okay, so this is my triangle. So tell me what the sine of 30 degrees is. Okay, what would you say the sine of 30 degrees is? 1/2, right? Because opposite over hypotenuse, 1/2. Now, go to your calculator, check it out. Or if you have the unit circle, check it out. It should be 1/2, right? So all of this, these 4 pieces of information will fill in the whole unit circle. So that's all you need to know. So you should be able to find the values for 30, 60, 90, 45, 45. You should be able to find pi over 2 pi, 3 pi over 2. This is like 99.9% of everything they'll ever ask you. You can just off of these 4 little diagrams, you should be able to figure everything out. Okay? Does that make sense? How to come up with values without using your calculator. All right. So now we're going to find what is the derivative of sine and cosine. The derivative of sine, okay? So if I said, okay, I've got y is equal to the sine of x, I want to know what the derivative of that is. Well, the derivative of sine is cosine. That's it. That's the whole thing. Now, if I said y is equal to cosine and I wanted to know what the derivative of cosine is, the derivative of cosine is negative sine of x. Okay? Now, what do you think this means? Y to the 1, 2, 3, 4. What do you think that means? It means the 4th derivative. Okay? Sometimes they'll write it this way. Sometimes they'll write it like this. But most of the times they'll do it like this. So what if I asked you for y double prime of sine of x? Okay? So what I do is I always look at it, it's like, okay, oh, no, that is not. The derivative of sine of x is cosine of x, right? So that's y prime. So that means I want to take one more derivative. So I've got to take the derivative of cosine of x, right? Because that'll give me my second derivative. So my second derivative is negative sine of x. Boom. So I want you to tell me what I want you to tell me the 4th derivative of sine of x. What is the 4th derivative of that? Okay. And that's, once you understand that, then all of these are pretty easy. So I've got, I'm saying y, okay, so y is equal to sine of x. And I want to know what y quadruple is. Stuck, okay? So what I do is I look at it, it's like, okay, this is the sine of x, that's y is equal to. First derivative, well, the derivative of sine of x is cosine of x, isn't it? So now I'm going to take the derivative of cosine of x. Well, we already said the derivative of cosine is negative sine, right? Ah, okay, so now there's really a -1 in front of here. So now what is the third derivative of sine of x? Well, I got sine of x, cosine of x, negative sine of x. What do you think this is going to be down here? Well, it's going to be negative cosine of x. Yep. So what is y, the fourth derivative? Well, we know cosine of x is equal to negative sine of x. So what's the derivative of that? Yes. I've seen this on a AP exam where they ask for the sixth derivative. And it's like, well, all you're doing is, okay, 1, 2, 3, 4, 5, 6. You just keep going back, and it's just going to be a rotation now. It's just going to keep going over and over and over again. Okay. What do you think this derivative is? So let me say I gave you y is equal to 3 cosine of x, and I want to know what the derivative is. Okay. What do you think the derivative of 3 cosine of x is going to be? Oh, no, 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 no. No. We're dealing with cosine of x. What is the derivative of cosine? The derivative of cosine is negative sine of x. Now, does it matter if there's a number in front? Absolutely not. So my answer is just going to be negative 3 sine of x. That is absolutely correct. Okay, now I'm going to take everything that you've just learned, and I'm going to give you one problem that will tell me if you know what you're doing or not. I've got y is equal to sine of x. I want you to write an equation of a tangent line at x equals, let's see here, pi over 2. And that really is 90 degrees, right? So I want you to write an equation of a tangent line at pi over 2, or 90 degrees. Okay. Let's see. It's a pretty tricky one. I'm trying to trick you a little bit. You're stuck. Okay. Now, let me graph this out for you. Okay. So what I'm really asking you to do, this is a sine graph, right? Goes up to 1, comes down, goes back up. I'm really asking you to draw, because when you think of it visually, and that's what I always do, I think of what visually it's going to look like. This is pi over 2 here, right? I'm trying to write an equation of a tangent line at pi over 2. That's the equation of the line that I'm trying to write. Visually, that's what I'm looking for. So what is your answer? What would that equation be? And then I'm going to do it algebraically and show you that we get the same answer. Okay. Y is equal to 1. I agree, 100%. Okay. Now, algebraically, I'm going to do the same thing. What do we need in order to write an equation of a tangent line? We need point and slope. Okay. Well, the point we already know is pi over 2, comma, pi over 2, 1, isn't it? That's what this point is right there. That's what my point is. I could have plugged in pi over 2 here into my calculator, and lo and behold, my calculator is going to tell me it equals 1, right? Hopefully. Do you have a calculator on you? Okay. Put in sine of pi over 2 or sine of 90. I don't know if you have your calculator in radian mode or degree mode. It does make a difference. And you got 1. Okay, so there's my point. Now I need my slope. Well, how do I find slope? I have to find the derivative. Derivative of sine of x is cosine of x. So this is going to give me the derivative or the slope at any given point. Well, I'm at pi over 2. Quickly in my head, this is what I draw out. That's pi over 2 right there. That's equal to 0, isn't it? So my slope is 0. So if I write my equation, I've got y minus 1 is equal to 0, x minus pi over 2. Well, guess what? 0 times anything is going to be 0. So I end up with y minus 1 is equal to 0. Put the 1 over there. Y is equal to 1. Lo and behold, algebraically, I get the exact same answer as I would visually. Does that make sense? I mean, I've been going through a lot, but I really enjoy the trig stuff. Once, I mean, man, even all the way through college, I did not understand this stuff. But when it clicked, it's like, oh man, all I need is these pieces of information. I need to know what the sine graph looks like, the cosine graph looks like, and then the two special triangles, the 45, 45, 90, and the 30, 60, 90, and I've got most of the values I ever need. All right. Yeah, I don't have the unit circle memorized either. No way, no how. All right, so give me some answers here. What is the derivative of 2x minus 3 sine of x? And now these are just derivatives. You should be able, just like that, you should be able to give me the answers to these, right? And obviously, it's adding a little bit from last week on there also, right? Because we've got 2x. So 2 minus 3 cosine of x. I agree 100%. That is correct. How about negative 2 cosine of x plus the 3x to the third? What is the derivative of that? And that's why I said this week, you're going to have to know the sine and cosine derivatives. And they're really pretty easy, right? Derivative of sine is cosine. Derivative of cosine is just negative sine. So that would be positive 2 sine plus 9x squared. Absolutely. That is it. That is 2 trig functions, okay? There's more. I mean, there's 4 more. All right. This one's yours. Find the equation of the normal line. Okay, now it's a normal line. So that's perpendicular to a tangent line, right? Okay. Find the equation of a normal line of f of x equals sine of x plus cosine of x at x equals pi. I believe this is a problem off your assessment this week. I'm almost 100% sure this is a problem off your assessment this week, okay? So what I want you to do is I want you to try it, see what you get for an answer. And I will turn off my mic and let you do some work. And if you're stuck, you can say that. I mean, it's not a biggie. Pi negative 1, okay? So in order to find my point, and you're right, that's exactly what you should be doing right now. You should be finding point and slope. So we know the point is pi, and then I'm going to take pi and put it in here. Okay, so again, I need my graphs all the time. Okay, so that would be 0. Sine of pi is 0. Cosine of pi is negative 1. So 0 plus -1. So yes, my point is pi -1. I agree 100%. Yes, you are correct so far. I am sorry. You are absolutely correct. The slope of the tangent line would be -1, and the slope of the normal line would be 1. That is absolutely correct. So now it's just basically writing our equation. We've just got y plus 1 is equal to 1 x minus pi. And I would just leave it just like that. I would not try to rewrite that into slope-intercept form because that would be a pain. Just leave it. So many students are writing things in slope-intercept form. I just think they're not watching the main lesson recordings. Would be my guess. All right, so pretty easy, right? Not bad. Now here are the other 4 trig functions, okay? And these, as I said, I don't memorize these. These are the 4 other ones. And all I do is I just, I have a 3x5 card next to me. And when I have to do the derivative, I just look at it and it's like, okay, because I don't think I've ever seen, I shouldn't say ever, I might have seen once or twice, I might see a derivative of one of these, but rarely will you ever see anything like this. So I don't make kids memorize this because there's enough to memorize in class that this would be a little bit too much. But I mean, if you have a good memory, go ahead. So these are the other 4. Oh, absolutely. While you're taking your test, you absolutely can. And as I said, you're going to be doing these so many times that it'll be ingrained in your memory by the time we get done with this semester. Okay, so here's a problem. What is the value of the derivative of tangent of x at pi? Oh no, Mr. Shanklin, how do you find the point of tangent? Okay, well, first of all, we need to know what the derivative of tangent is, and that is secant of x, right? Oops, my marker's not working. Yep, so that's the derivative. Okay, so now what is secant squared of x? So now what I need to know is I need to know the secant squared of pi. Well, how do you do that? How would you find the secant of pi? And how are you going to use the cosine graph? There's the question. I mean, I don't disagree with you. Okay, but why? How can we use that? Exactly. Secant is 1 over cosine. No, you are absolutely correct. So what we could do here is we can just rewrite this as 1 over cosine squared of pi. Okay, and what is the cosine of pi? And when I see something like this, this is what I see in my head. I see cosine of pi squared. That means exactly the same thing. So it's -1, right? Okay, so that means I have 1 over -1 squared, which is 1 over 1, which is 1. The derivative of tangent at pi is 1. Very good. Awesome. All right. Here's another one. What is the cotangent of if y is equal to cotangent of x, what is the value of the derivative at pi over 2? Okay. I'm going to let you do this one and see what you get, and then I'll go over it. I'm sitting here yapping away, asking you questions. All right. So the derivative of cotangent, that was my question. What was the derivative of cotangent? Is negative cosecant squared of x. Okay, well, that's 1 over sine, isn't it? So when I look at this problem, this is what I see. Okay, pi over 2. So I'm going to put pi over 2 in here. Again, real quick with sine, pi over 2 is 1, so that's going to be -1. -1 squared, that's going to be 1 for my answer. So you are absolutely correct with 1 as an answer. All right, awesome problems. Now we have other derivatives tonight also, derivatives of exponents and natural logs. The derivative of the natural log, okay, the natural log is really e to the x. The derivative of e to the x is e to the x. It is the only function that has its derivative as its own function. E to the x, the derivative of e to the x is e to the x. Okay, that one's so easy to remember. So if I gave you this problem right here, if I said, I have y is equal to 6 e to the x, what is the derivative of that? What would you say the answer is? 6 e to the x. Absolutely correct. That's a tough problem. Okay, so here are some problems. Find the derivative of each. Well, got 3 e to the x. Well, that's just 3 e to the x. I've got x squared plus e to the x. No problem. 2x plus e to the x. Got sine of x, cosine of x. Boom. Remember when we first started doing these derivatives and I made you do them using the longhand form where we had to find the limit as h approaches 0 of f of x plus h minus f of a over x minus a? What a pain that was. Now you should be able to, whoa, sorry, I almost fell off my chair. My daughter got me one of these stools that supposed to be good for your core. sometimes I fall off of them. All right, so here's a problem. It says let f of x equals 2 e to the x minus 5 cosine of x plus 3. What is the derivative of that? Two e to the x minus or plus 5 sine of x plus 0. Very nice. You've got your derivative. There's only 2 assessments, I think, this week. You're going to be done with them in no time. All right, here's my favorite question. Find, and I didn't put any of these on the, oh yeah, I think I did. Find the equation of the tangent and normal. Yeah, exactly. But it is working right now, I think. I just jumped in there and it was working. So yeah, but it's done that all day long. It works for like 5 minutes, and then I can jump into my classes, and then nobody else can get into them because Blackboard's not working. All right, so in this problem, it says find the equation of the tangent and normal lines f of x equals 2e to the x when x equals 0. Okay, so I want you to find the equation of a tangent and normal lines to that. 2, what is 2? Is 2 your equation? That's your slope? I agree, the slope is 2. Yes. What is the point? Because remember, you need a point and a slope in order to write an equation of a tangent line, right? So what is the point? 0, 2 is correct, right? Yeah. So your point is 0, 2. Your slope is 2. So if you want to write an equation, I mean, now we've got all the pieces of information. I've just got y minus 2 is equal to 2x minus 0. And if I wanted to write the normal line, that's going to be negative 1/2, isn't it? Because it's opposite reciprocal. So y minus 2 is equal to negative 1/2 x minus 0. Done. How easy is that? There, I like these types of problems. As long as you understand the derivative, they're really pretty easy. Okay, now we have one last type of derivative. This is called the derivative of natural log. This is a natural log of x. So if I give you the derivative of natural log of x, your answer is just 1 over x. That's it. So if I said y is equal to, y is equal to 6 natural log of x, you would say the derivative is 6 over x. This part here is always just 1 over x. So if I had a 6 out in front, it's just going to be 6 over x. That is the last derivative of today. So what are my answers? And this is, I mean, this is as hard as you can make them because you're just putting everything together that we've learned, right? I mean, we've got a sine here, we've got a natural log here, we've got a whole number here. So that's basically it. So you've got 12x to the third minus 7 over x. Right, that is correct for the first one. Very good. So let me write this down for kids that are watching it. 12x to the third minus 7 over x. Done. Okay, and then what is the last one? Because I don't think when you watch recordings, do you see the chat? I don't think you do. I'm not 100% sure. You do? Okay. Okay, so the chat's still there. If you, I'm saying if you're watching a recording. So if you're watching a recording, you still get to see the chat? Okay, did not know that. All right, so let's see here. You said the answer was 4 cosine, negative 4 cosine of x minus 9 over x plus 0. Boom, done. That's it. I think that was the last question for today. That was it. So we have, you know, we talked about what, 8 different derivatives today: sine, cosine, tangent, cotangent, cosecant, secant, e to the x, and natural log of x. All of them are, well, I take that back. They're not all important. Sine, cosine, e to the x, and natural log, very, very important. Those other 4 trig functions, yeah, you'll see them in homework assignments, but you're not going to see them, you know, if you take an AP test. They don't show up too often. But, you know, it would, you know, just as long as you've seen them, so you know what you're doing with them. All right, that is it for today. Any questions? The practice link on the PACE chart does not work. How do I access the practice? Okay, now, the practice for this week, isn't that in, are you signed up for the AP Classroom? Okay, can you go into the AP Classroom right now? Because that is where this week's practice is. Okay, so let me pull up my AP Classroom. Okay, because I believe I did not look at the pace chart for this week. Let me look at the pace chart if I can get into it. But doesn't it tell us that we have to go to the AP Classroom? Let me look at the pace chart here. So week number 7. Okay, week number 7. Weekly practice. Please email me your results for the practice so I can open the weekly assessment. Yeah, but so it doesn't say it there. Darn it. I wish I would have put that in there. I thought it was in. I really should change that. But I believe the practice for this week is in the oh, I put it in the Khan Academy doc. Okay. So were you able to get into the AP site? So I'm in it right now. I haven't gotten into my classroom yet. I always have such a tough time maneuvering around this site. It's not the most friendly site, I don't think. Okay, so I should be signed in here, but it should have something that says week number 7 practice. Yes, practice number 7. Agreed. Do you see it? Okay, so all you have to do is take it and then just send me your results, and I will open up the assessments for the week if I can get in the Blackboard, which is a little bit iffy right now. All right, so that is it for this week. Any questions? All right. Hopefully we'll see you back next week, same time, same place. I'm not sure what we have next week. I'm waiting till we get to the chain rule, because the chain rule is, oh, we have the product rule and quotient. Ooh, those are tough too. All right, so we've got a couple tough weeks coming up. The product rule and chain rule, and then or the product rule and quotient rule, and then the chain rule. Two things that a little bit tough, but you'll have no problems with them. All right. Have a great week. We'll see you next week.